All right. Good afternoon, everybody. So now let's look at this question, still on triangular forces. Okay, triangular of forces. So I've stated it already that it states that when three coplanar forces are represented in magnitude and direction by the sides of a triangle taken in order, it is in equilibrium. So now these are two questions, all right, to quickly attempt on triangular forces. So the first one says this is the first diagram, okay, this one, and this is the second diagram, these two. So what's the first talking about? It says a body of mass 0.5 kilogram is suspended by a string and pulled by a horizontal force of 12 Newton. All right, so it was pulled by horizontal force of 12 Newton. You can see the direction of the three forces or three coplanar forces, okay, of 12 Newton as shown above. Okay, full stop. Calculate the tension T. Where is our tension? This is our tension T in the string. Okay, if in the string, comma, if the body is in equilibrium. So we are looking for this tension, all right, if the body is in equilibrium. Now, the mass that was hung was 0.5 kilogram. So the mass was actually pulling the load here downward. So that means the mass here is 0.5, okay? Then gravity is 10, so G is equal to 10. So mg, to find the weight now, W, of course, weight is equal to mg. We all know that. So the weight acting downward is going to give us what? 0.5 multiplied by 10, which is what? Which is 5 Newton. Okay, that means a force, all right, or a weight of 5 Newton is acting downward. A force of 12 Newton is here, then your tension T is going this way. Right, cool. So now to resolve that, it's actually very simple. We have seen the question already. So I'm going to erase the this part so that I can solve it. So now I said you are going to turn these three forces first of all to what? Three different what forces into a triangle. Turn those three different forces into a triangle. Then resolve it using SOHCAHTOA. So to do that quickly, now we have this cleaned. Okay, so we know what O's already. So let's clean erase this part from it. So for that now we now have this. Okay, so a force is going upward like this. So you can see the direction of the forces like this. So I have something like this. Okay, so put the direction in that place. What is here? This tension. A force was acting downward. So this is a force acting downward, all right? And we calculated already that that force is what? Mg, which is 10. Okay, so that means, which is 5 Newton rather. So that means we have what? 5 Newton here. Then a force was going like this. So that means a force was going in this direction. Okay, and that force was 12 Newton. So we can put direction 12 Newton. So I've been able to resolve everything into what? Into a triangle. Okay, so then I can now solve. All right, so if this is the case, this is 12, right? So this is the hypotenuse side. Okay, then if this hypotenuse side, this will give us the opposite because 90 degrees here, this opposite, while this one is what? Is adjacent. So how do we calculate for tension? The only way we can calculate for tension here is to use what? Pythagoras theorem. What is Pythagoras theorem? It says hypotenuse squared is equal to opposite square plus adjacent square. Okay, this Pythagoras theorem. So what is hypotenuse square? That is t square. So that is t raised to power 2 is equal to opposite square. That is 12 raised to power 2 plus adjacent square, that is 5 raised to power 2. What do we have? T square is equal to 12 square give us what? 144, then plus, okay, 5 square gives us what? 25 Newton. These are the options. Then we have T square is equal to, if you add 144 plus 25, we have what? 169. So take the square root of the both sides. T square in square root is equal to what? 169 in square root. Okay, this one has gone. That is T square into square root. This one has gone is equal to square root of 169. Then T is equal to root 169. The square root of 169, all right? T is equal to root 169, and square root of 169 gives us 13. So that means T is equal to 13 Newton. Okay, that's how to attend to what? The first question. So 13. All right, so now we can pick option A as the correct answer. Now, but for the next one, question number 2, all right, this is what we have. Now, we must understand that in triangular forces, some of the upward force, if I have a force like this, all right, coming down, and I have a force acting downward, the sum of the upward force here is equivalent to the sum of the downward force acting downward, acting towards this side. Okay, now I'll first of all resolve these two. I have tension 30 degree 30 degree, and the force is acting downward. In other words, these ones are upward forces while these ones are downward forces according to the arrows. All right, so to resolve, okay, let's see what we're going to be doing. We are first of all going to resolve this into what? A vertical component of a force. Okay, so to do that, what's going to happen? We have done with this already, so let me do something here. So we have 13 Newton for the first one. Then for the second one, all right, so what do we have? So let's do that. We're going to resolve this to vertical component, this to vertical component. So our diagram becomes something of this nature. Okay, so what do we have? This is vertical, and if it's vertical is now t sine 30 degree. We know that vertical component of a vector. Then 30 degree here is also what? T sine what? 30 what degree. We have resolved this to vertical. Horizontal component of a force is t cos theta, all right, or f cos theta. While the vertical component is what? Is t sine theta, or what? Or f sine what? F sine theta. Those are components of the vector. Then we have 20 acting downward, 20 Newton. Don't forget that I said sum of the upward forces is equal to sum of the downward forces. So now these are the upward force because these forces are upward. So we have two upward forces, t sine 30 degree, t sine 30 degree, all right, because we have resolved this into what? A vertical component. So we have t sine 30 degree, all right, plus, because upward force is first, plus t sine 30 degree. Okay, then everything is equivalent to downward force, which is, what is our downward force? The force that's acting downward is what? Is 20 Newton. T sine 30. Now, what we did here is upward force is equal to downward force. Okay, that's what we did. Then t sine 30 degree, sine 30 is 0.5. That is t multiplied by 0.5 plus this sine 30 is also 0.5. That is t multiplied by 0.5 is equal to 20. Okay, t times 0.5, that is 0.5t plus another 0.5t. Everything is equal to 20. So 0.5 plus 0.5 is 1. That is what? 1t is equal to what? 20. Then 1t is also t. That means our answer is what? T is equal to what? 20 what? 20 Newton. All right. So that is basically how to resolve that. So where's the option? Option C is the correct option. 20 Newton. So that is how to resolve the other examples of triangular forces. Thanks for watching and God bless you.